Excuse me, ma'am. Hello. Will you repeat?
Okay, so last time we have seen the distribution Poisson and the binomial distribution. So out of that discrete random variable we have seen. So now for continuous random variable, we have two distributions. So one is exponential distribution and the other one is called as the normal distribution. The random variable is continuous random variable, continuous random size n. So here the sample size is very large. So n is tending to infinity. Okay, n is very large. So the number of trials are very large. N is very large. Very small. So in this case, whenever we have this kind of situation is given, then we are using the normal curve is given by the equation is given by the equation mu bracket square divided by 2 sigma square. So you can see that here mu is the mean. Okay, mu is the arithmetic mean, and distribution curve, which is given by such a nice function. But you can see that it is whenever we are plotting this kind of curve, it will look like this. It's symmetric kind of curve where we have this is your since it is a distribution function, we'll have this at minus infinity to infinity. Y dx is always going to be 1. Okay, so that means the area under the curve for this curve is always variable. It is not like the whole number, the way we have seen it in the earlier cases. So here we have the continuous random variables. So all the values are given in bunches, correct? So they are all real numbers. We can see that whenever we want to calculate, suppose the area under the curve. So suppose I just take these two values, correct? This is your strip, red strip. Probability for the value of random variable lies in between x1 to x2. Then it gives that since being a continuous random variable, will have this function will look like this. So here it is in So this normal distribution is also written in this form. It is normal distribution. We are just transforming this to the value of mu as 0. So it will be get shifted. So here we always get again the normal distribution is a limiting case of the binomial distribution where n is tending to infinity and neither p nor q is very small. So from the distribution itself, and this is being it is a probability distribution. So let us see the actual formula or working formula of this and we'll calculate it. So here what we do whenever this is our normal, as I said here, it is our probability density function or mass function of the normal distribution with a mean 0 and the variance is 1, correct? And the variance is 1. So if x is a normal variate, if x is a variate, normal variate, deviation is sigma, standard deviation is sigma. Then we write here, then we just substitute z as x minus mu by sigma. Okay, x minus mu by sigma, and standard normal variance. We are going to write it down that function as say px, which is equal to, we have 1 upon sigma square root 2 pi sigma square. Then what is x? X is always lies in between minus infinity to infinity. X is the random variable, continuous random variable, and it takes the value as the real. We calculate this probability density function. So whenever actually we are calculating it for the examples, so how to calculate the probability between the two values, okay, or greater than 1 or less than 1. Calculate the probability for mu less than x less than say x1. Mu less than x is less than x1. So actually what we are doing is we have this curve, okay. What we are doing is this is of this using the definition of probability density function for continuous random variable, we have this as mu to x1 p of x dx, correct? Px dx. What is our probability density function given? Mu bracket square divided by 2 sigma square dx. 2 sigma square dx. So let us substitute, as we have seen the standard normal variate, we are taking it as z, and that z is. So what do we get this as dx as? So it will be x minus mu is equal to sigma times z. So we get dx is equal to sigma times dz. Let me talk about the limit. So here x is x is equal to mu. What is the value of z? You'll get this as mu minus mu by sigma, which is 0. So that means the value of z is from 0. And at x is equal to say x1, this limit will get changed and the limit can be written as mu is now becomes 0 and at x1 we'll call it as z1. I just minus mu by sigma whole square in the power. So it is like minus of z square by 2. Correct? We are putting z as what? X minus mu by sigma. And I do have in this case numerator term square as well as denominator term. So let me write it down that. So this sigma will get cancelled. And we can see nicely here 0 to z1. Z1, we have 1 upon square root 2 pi e raised to minus z square already calculated and the tabular form is given. Okay, tabular form is given and that tabular form, the values for the tabular form will be given in your paper also. Okay, so you don't have to let us see probability for 0 less than z less than 7. Okay, so this is get transformed to a new values and we get the new function. The standard normal curve and that is in between 0 and z1, z equal to 0 to z1. Okay, so the problems based on this are too simple. So let us see the problems of some time. So the example, assuming that assuming that the diameter the diameter 1000 plus taken consecutively taken consecutively consecutively normal distribution with with mean mean is 0.7515 as 0.0020 centimeter. So the question is how many of plugs how many of plugs approve approve if the acceptable diameter if the acceptable diameter 0.004 centimeter. Given that, given this will be given in paper also. So given area Z is 0.4878 and the area is 0.4599. 0.4599. So these are the areas provided, and we have to calculate the acceptable diameter. We want to find it out, the number of flux that is likely to be approved, correct? And we have here 1000 flux actually. One can extend it this value. Value, since it is given that it is normal distribution, so of course we are going to use in this case a normal distribution formula, that is density function in this case. The mean value is given as, so here mu is provided, mu all or the variance is provided, that every time you have to keep check. Sometimes variance will be given in the paper, and then you have to calculate square root of that value. Now what is given? The acceptable diameter is tolerance level actually for the diameter. So what I do is I just take the first value. So x is equal to 0.752 plus 0.004. This is the first value of x. And the second value, let me call it as x1 and x2. x2 is 0.752 minus 0.004. So this we have to calculate. So let us have that 0.004 is 0.752, correct? 0.004 it is 756, correct? And minus 2 means we'll get minus 0.004 means we'll get this as 0.748. 48 plus 4. So we'll get this value of x1 and x2. Now what I have to do is we have to always take the standard normal variate. So this is the process actually. So we always take this as z as x minus mu by sigma, where we have x minus mu is given as 0.7515 and divided by sigma, the value of standard deviation is provided as 0.0020. Okay, so this is our standard normal variance. So actually we are interested in calculating this just by putting the values, okay? And we do have the integration for minus infinity to infinity of that density function is also provided, correct? And that value is 1. Now what I have to do is, first of all, you always transfer it to the z variant, okay? What I need to find it out here, the probability for 0.748 less than x less than 0.756. This actually we have to calculate, correct? This we have to calculate. So for this, what we do is we just try to transform it to origin, means 0 with the variance as 1. So what we do is we just substitute the value of x1 and x2 in place of this x, okay, here. So let us solve this. So what we do is we substitute now x1 there, 0.756. So z is what? Z is x minus mu by sigma. So for x is equal to 0.756. Okay, what will be Z1? Z1 can be written as 0.756 minus what is our mu? The value of mu is given as 0.7515 0.7515 divided by the standard deviation 0.0020. So calculate this, calculate this. See, you will get that value as 2.25. Okay. And for x is equal to, or for x1 and x2, for x2 is equal to 0.748 we have got. So that is, we'll get the another value z2, 0.748 minus 0.7515 divided by 0.0020. So what is the answer we'll get? This is minus 1.75. Okay. Now we will draw this diagram. Okay. So always draw the diagram so that it is very easy to understand the thing. Now we have the value of this. Okay, what we have the probability. Actually, we are calculating it for 0.748 less than equal to x less than equal to 0.756. Now this is equal to the probability where it is mapped in z variable. Now the next standard normal variate is what? We are taking it as z. So for 0.748 we have got the value as minus 1.75, and for 0.756 we have got it as 2.25. Now this is negative, correct? Negative. So this is your origin actually. When I just put x as mu, we just shifted to origin. So minus 1.75 is somewhere here. Let us say that this is your minus 1.75, correct? And where do we have this 2.25? It is somewhere here. We call it as say Z2. So Z2 is say 2.25, correct? What we want the area under this curve. So that means I want this entire area. Yes, I want this entire area. Okay. Now what is given to us? What is given to us? So let us see the part which we have seen it here. So here what it is giving? It is giving the area for probability for 0 less than z less than z1. So every time I am getting the area under the curve from origin, correct? From origin, not from minus infinity to that value. So if it is minus infinity to that value, then it will be what? It will be 1, correct? See, in this case, so this area under this curve is what? It is actually 1. Everywhere it is 1. So if you divide it in two parts, being the symmetric part, so the area here, okay, in this region is what? It is going to be 0.5. Here in this region, it is also going to be 0.5, because this value we are transforming it to 0, correct? Transferring it to 0. So you can see that the value always is provided from 0 less than z to less than z1. So this value has to be always less than equal to 0.5. 0.5, correct? 0.5. So here what we have in this case, we have this as minus 1.75 to 2.25. And what's the area given? You can see that. You can check your answers by given thing. You can see that one z is what? 2.25. Are we getting that value? Yes. The other z is what? 1.75. There is a difference. There is a difference of negative sign. That's okay. But then still we have the value as 1.75. And the areas are provided. You can see that the areas are less than 0.5. Correct? Areas are less than 0.5. That means they are given from 0 to that value. So from 0 to 2.25, what is the area given? 0.4878. Correct? So this area from 0 to 2.25, this area is given as, let me call this area as say A2, and this area is given as 0.4878. Correct? Now being it is symmetrical on both sides, okay, this part is symmetrical. So the area, when I take here 1.75 somewhere here, so this area, okay, this area is same as the area on this side, being it is symmetrical. So whatever the area we have it from 0 to 1.75, the same area we have it from 0 to minus 1.75. That you have to check always. Okay. So here this area, what is given? The area is given as 0.4599. So this area is what it is here, 0.4599. I call this as area as A1. Okay. Now what our job is to find out the area for this pink shaded region. That means the entire from minus 1.75 to 2.25. So how you do this? Of course, we'll add it, correct? Of course, we'll add it here. So this is equal to, what I have to do is, I have to just add this 2. So what are the areas? It is 0.4599 plus 0.4878. And calculate this. So we'll get this value as 0.9477. Okay. So this is the probability of acceptance for one plug. Correct? For one plug. Now we are evaluating it for how many plugs? 1000 plugs. Correct? 1000 plugs. So what I have to do is, so the number of plugs likely to be approved or acceptable. Correct? Approved is 1000 into this 0.9477. And what will be the answer? We'll get this as, there are 3 zeros. So it is 947.7. You cannot say the number of plugs in real numbers, correct? So we always round it off. So here it is approximately how much? 948 plugs. Okay. So whenever the machine is producing, say 1000 plugs, out of that 948 plugs are acceptable, approximately. Correct? They are in that diameter, accepted diameter. Are you all getting it? So here you don't have to calculate the integration. The areas will be provided, just you have to draw the diagram properly. So being a symmetric curve, always understand that if the area is provided as 0.5, less than 0.5, then the values are given from 0 to that particular answer. Okay. If it is greater than 0.5, that means in this case you have to subtract 0.5 from that. So in some of the tables, they may give you the answers from 0.5 onwards. That means they are considering from minus infinity to 0. That value is considered as 0.5 plus the next values, area under the curve. So that value will be greater than 0.5. Then you subtract 0.5 to get the respective area. So let us take one more problem. So another example is, in a certain examination, 2000 students appeared in a subject of statistics, stats. Average marks obtained were 50%, which is too less actually, with a standard deviation 5%. This is also very small. That is, maximum values are near about to that average. Correct. So how many students do you expect to obtain more than 60% of marks? Supposing that marks are distributed normally. So whenever we are saying this, we are changing those x variate to the normal distribution variate, correct, by using that function. That function actually maps all the values to normally distributed curve. Now, what is given? Given area corresponding to z is equal to 2 is 0.9772. 0.9772. Okay. Now, what is asked here? First of all, so being normal distribution is given, so everything becomes simple, as I said. So what we have to do is we have to just take first of all average mark. What are the average means? Here we are denoting it by mu. 50%. 50% means what? 50 by 100. Correct? So it is 5 by 10, which is half, and that is your 0.5. Correct? And what is sigma? The standard deviation is given as 5%. So sigma is 5%. That means it is 5 by 100. So we get that value as 0.05. Now what I have to find it out? I have to find it out the student getting more than 60% marks. So here actually marks is nothing but your random variable. Correct? Random variable x. We want the probability for x greater than equal to 60% that we want to calculate. The meaning of this is what? Probability for x is greater than equal to, you just take 60 by 100. What is this? It is nothing but probability for x is greater than equal to 0.6. Correct? This is our random variable. Now, in this case, what we are going to do is we will calculate the value of z. So for what is z? It is x minus mu by sigma. So for x is equal to 0.6. What is the value of z? Z is written as 0.6 minus 0.5 divided by 0.05. So we'll get this as 0.1 by 0.05. So that means we'll get it as 2. 5 2s are 10. Correct? So we get this value as 2. So z is 2. We are getting z as 2. So that means this probability is actually when you transfer it to z, it becomes z is greater than equal to 2, or it is same thing as z is strictly greater than 2. It's one and the same thing.